Types of error. We went over this last time, I think. Remember types of error? So just add this to the notes from last time, would be fine. Types of error, you have a type 1 error. Type 1 error, you reject the HO, and the HO, the null hypothesis, ends up being true. A type 2 error, you fail to reject the HO, and it ends up being false. Sometimes a type 1 error will be bad, sometimes a type 2 error will be bad. Depends on what the situation is. I'm sorry, I forgot. Yeah, I'm doing it right now. Does everybody have that? I'll change the slide so we can go on to the next one while I do this. Alright, we'll probably, this one, I don't know if we want to use sigma or we want to use whatever we use. We could use mu probably. So mu equals what? 3. That's our statement. That's the statement that we're making. It's going to snow 3 inches. So our HO equals 3 inches. What would our HA be? Not 3 inches. So this is our null hypothesis, our alternative hypothesis. What's a type 1 error going to cause? What happens with a type 1 error? We reject the null, and it ends up being true. So we say, it's not going to snow. And what happens? We get 3 inches. All right? Type 2 error, we fail to reject it, and what doesn't happen? It don't snow. That's like what happened the other day, right? Said it was going to snow 3 inches, didn't snow. Which one of those is worse, a type 1 or a type 2? We say, we don't even tell anybody, it's going to snow 3 inches. We say, it's not going to snow. So we reject the HO, and then it does snow. Is that worse than telling everybody it's going to snow and then it doesn't? Yeah, the first one's probably worse, right? Because then all of a sudden, nobody's prepared for the snow. 3 inches probably wouldn't really matter, but let's say you were out on the East Coast this week. And they said, oh no, it's not going to snow any. And then all of a sudden you're got 18 inches of snow.
See, there was somewhere supposed to get 20 and they got like 22 or something.
Yeah. So you get that much snow, do you probably want to know that before it hits? Yeah, you want to be prepared for something like that. We usually don't have that much here where you don't see a whole lot of times where somebody snowed into their house and can't get out for a week or something. All right. Now, it did, when I was in school here back in 1978, we had the blizzard, and out towards Grant's house, actually on over towards like B Road and stuff like that, those people were snowed in for like 2 weeks. They couldn't get out of their houses for like 2 weeks. So they had people that hauled stuff on snowmobile from El Dorado out to those people to get them food and water and everything else. We haven't had any snow like that for a long time.
You said that this winter.
That would be awesome.
That would be.
Actually,
How much snow actually was there for that?
there's a bunch. I had pictures. I can't remember what is the name of that road. Not B Road. What's the one that runs across from like Lips's house all the way down to your past your grandpa's house and down to
Schumann?
Yeah, I was thinking of
Schumann?
Is it?
Dark County Line.
That's not Schumann, is it?
That's what I
Shirley?
thought.
So
You know what Shirley?
your dad's road's here.
My road? My road's the other way.
All right.
You gotta draw this house.
I'm drawing it this way, Grant, you can turn it in your head. El Dorado is up here, alright, so this is El Dorado. You got Schaeferville down here, alright? What's this road?
That's Dark County line.
Yeah, Dark Carolina.
Nah, it's not Dark County line.
It is.
Yeah, it is.
I drive
Penn
that all the
Schumann
time.
is right there. On the-
Penn Schumann's on the other side of Schaefer's.
You got the other road that comes out of El Dorado, and it's got that S curve right
That-
there.
That would be
Okay,
Monroe, I think.
That-
Monroe.
No, you guys are looking the wrong way.
That's sure.
Monroe's on the other side.
That's
Sure.
either.
This is like B Road or something.
It's either-
And then you got another road down here
Lee.
that's Lee Road.
Yeah.
Oh, that's,
I get them mixed up.
Is that
Okay, which Schaefer are you talking about?
Schaeferville, where all of them live?
Oh.
Here, I live on Shirley, so.
I'm not talking about Jesse's house.
Okay.
Jesse's house is like down here
The-
somewhere.
Okay, that long
There's
road
B
right there
road.
you're talking about,
B
that
road.
is Penn
Alright,
Schumann.
so which way
Yeah,
you wanna go?
is it?
Look, this is
Penn
B
Schumann
Road.
is like barely a road, bro. You like drop back.
Go
suspension
back.
on that thing.
El Dorado's down here.
It is
Oh,
bad.
hey, that's
Yeah.
Penn Schumann.
Yeah.
You should ride it on.
So we're looking at this
My
road
dad's
right here.
Harley Sportster. Oh
That
my
one.
god.
Penn Schumann. So it's Penn Schumann, it is Penn Schumann.
Cause that's
Alright.
where,
So people are stuck there.
People, all these people, and actually Mr. Curtin, 78.
You're still stuck.
Your folks, or, well, your
Mom's
grandma
from
probably would have
78.
lived out there.
Yeah, they went over the whole
I mean, everybody else is
Yeah,
young
Brian's
now.
parents were snowed in, bro.
Uh,
They lived there.
Mr. Curtin, who was the superintendent at that point, he lived on Penn Schumann. So we were out of school all the time, because every time it snowed, Penn Schumann was bad. But I was actually, when the blizzard started, he didn't live down this far, because if that's Schaeferville, he lived like over here.
We're recording, so.
That's all right.
where you just.
When I lived, or when the blizzard started, I actually stayed with my aunt. My aunt lived out here. Mr. Curtin actually lived on that side of the road. She lived across the street from Mr. Curtin, and I stayed there. And I was stuck there for like 5 days.
Is that down a long driveway?
No, it's not there anymore.
Oh.
The long driveway that you're thinking of, that's the driveway where they built something back in there now.
Yeah, that dude did not like.
He doesn't like me either, so. Because we did.
Are you talking about Brian Peck?
We did some stupid
No.
stuff. No, Brian Peck doesn't like anybody, but that's beside the point.
That's like. right
We
there.
did some stupid stuff because she lived here, and we used to go coon hunting in this woods back here. And so one night it was snowing pretty hard, and Grant's grandma got mad at me that night.
Oh, that's normal. She pulled a gun on Blake one day.
And I drove my little Monza back in there because we thought, I just came back from college, and we thought that some of our friends, Monza, we thought that some of our friends were back in there coon hunting, so we were gonna go find them, so we'd go out and do something. And across this big long driveway, there was a run, like a runoff, where water ran off and stuff.
Yeah.
So I took my Monza and we stopped right here, and I said, you know what, I think I'd make it. I didn't make it. And it got stuck right there, and it was snowing really, really hard that day. And we got stuck there. So I walked across the street to Mr. Curtin's house. He had a gun when he came to the door. I said, what do you want? I said, we ran my car in the ditch, and we're trying to use the phone to call somebody. And who did we call? We called Grant's dad because he had a big truck come pull us out, and he was just down the road.
When was this?
I was in college, so that'd been in like 86.
Before or after he wrote this trip? Probably before. Cause he had a collar after.
I don't know. It'd been close, I'm not sure.
He had a Caprice for like 5 years after. So it must have been before.
Yeah, I guess it would have had to been before because he didn't have the truck in. So we called him, and Marge answered the phone and said, "How are you doing?" And she didn't use that quite nice of language,
Yeah.
but what are you doing calling here? It's midnight. No, he's not coming out. No, he's not helping you. And
That's
But-
cool. But it's
long story, my car sat there, and the reason this guy doesn't like me, it sat there and it froze to the ground because it got real cold that night. So it froze in that little runoff. And the next day I went and got a buddy's backhoe, and we went out and we actually had to pry it up out of the ice and then drug it back to our house. And that guy somehow, I think I dropped my wallet when we were prying it up out there, because I lost my wallet somewhere in there. And he figured out who it was, and he came to my house and had the cops there and everything after me like 2 days later.
So you found your wallet.
So he probably found my wallet, and I asked him, I said, "Did you find my wallet laying out there?" No. I don't think, I think you did, otherwise you would have never known who it was.
You probably had cash in there in your pocket.
Yeah, I probably did have a little bit. At that point, I didn't care because I was mad at myself for being stupid. But anyway, then I was stranded out there for 5 days, and I had pictures. I was on probably a 20-foot snowdrift on the side of Penn Schumann. Huh?
Right there where you just circled Brian Harrison's old house was.
Yeah. So, and what we had to do is, so I could get home, because I had to, I delivered papers. So that I could get home and deliver the newspapers, I had to walk from out there into El Dorado after the blizzard was over.
Brian's house is before you.
Is it?
And then up there on,
That's Rose's house or something.
up in El Dorado on whatever the road is that comes in, what's the road that your dad lives on?
Me?
Yeah.
Elevated Whitewater?
So on El Dorado Whitewater, where it comes in that first street, what's the first street in El Dorado?
Jerry?
No, it's not Cherry, it's
I don't live in
Maple Street, I think, or something like that. So this is Maple Street here. When the blizzard started, a snowplow got stuck right in the middle of the road right there. And it had that whole road blocked off for like 2 weeks.
That sounds radical. Imagine having that much snow. I'd be stuck in the Schroeder somewhere.
Too far. All right, remember, this is some stuff that we talked about earlier this year, but might be something you want to write down. An unusual event, less than 5%. What we're going to be checking on this, P is our probability. If P is less than 0.05, less than 5%, then we're going to consider that an unusual event. And if it's an unusual event, then that probably means it shouldn't have occurred. So if we do a sample and it comes up in a certain range, we're probably all right. But if it comes up in one of those 5% ranges, either too low or too high, then that probably means, even though it was just a sample, it probably should have never ever happened. And that would show us that, hey, we probably want to reject the null hypothesis. Because samples vary, there's always a chance that you could reject the null when it's true. We talked about that. You can decrease the probability of what is happening by lowering the level of significance. We talked last time, remember alpha is level of significance. A lot of times we'll go with 5%. Other times we might want to lower it down to 1%. Other times, especially if it's like a medicine or something where it might be a health issue, we might jump it up to 10% because we don't want to take any more chances than we have to with somebody's health, right? I'm not going to give Sean this medicine and say, hey, Sean, this is going to cure the diseases you have if we're not completely and totally for sure about it. Now I say that and you see all kinds of stuff on the news right now where they're doing all these lawsuits against some of these medical companies because they somehow got things passed through that they probably shouldn't have. Level of significance, again, is your alpha. And all that is the maximum probability that we make a type 1 error, that we reject the null and it comes out to be true. We want to try not to reject the null and it actually be true, but a lot of times, especially with like medicine or something, we might fail on the side of caution, or error on the side of caution.
We're supposed to be writing those down.
Some of it. I would highly suggest that you write some of it. Some of it we wrote down last time too.
I was passed out.
Figure out what you needed. So if you get an A, that's what it looks like you figured out, wasn't it?
200 feet.
Divided that by 3. Did I put that on there, didn't I? I have to read it again, but 67. That's what you need to average. All right, level of significance. Again, it's alpha. By setting the level of significance at a small value, you are saying that you want the probability of rejecting a true null hypothesis to be very small. So that's sort of all it is when we're looking at our thing here. If we make the alpha small, if we make the alpha small, we're way down here. The bigger we make the alpha, the more chance that we're going to reject it, or reject the null. Because the more area we got there for it to fall into. The ones that we use the most, 10%, 5%, 1%. The smaller the value of alpha says you want a small probability of rejecting a true null. So you're trying to say, okay, we want to, this time we're putting the rejection value or the rejection area at something really, really small. So we're probably not going to reject the null. We're going to have a better chance of saying that the null is true. The bigger we make it, we could make it 50%. We want to make it 50%, then anytime our value falls in this area, we reject the null. Anytime it falls in this area, we accept the null, or we fail to reject the null actually. For some reason, if we want to go that far, maybe it's that big a deal, something where we want to be absolutely sure that something's not going to go wrong. Okay, if we went up to like 50% or 70%. Might even go up to like 90%. And I think one of the examples on here talks about chances of a parachute not opening once it's packed. Well, we probably want those chances. We probably want, when we want to reject, we probably want that area to be pretty big and the area where we accept it to be pretty small, because we don't want any chance that that parachute's not going to open.
There's always a chance.
Yeah, but we want it to be as small as possible, right?
You ever skydive?
And went to do it once and they wanted like $250 to do it. And I said, okay. Right. Probability of type 2 error is beta. Beta actually has something like that. It's called power of the test is 1 minus beta, and that's the probability of rejecting a null when it is false. So that's our power of the test. That's like saying we're going to reject the null and it is false. That's telling us, hey, we're probably right, or we're correct, because we rejected it and it was false. I don't think we use power of the test a whole lot, but just to be on the safe side, might be something you want written down. 1 minus beta. That's right. I'm not doing anything right. do a statistics test. After stating the HO and HA, specify the level of significance. Don't write any of this down because I think we're going to do this on the next, on a couple other slides. Then a random sample is taken from the population. You can't ever do the random sample first, because if you do a sample first, what's that going to do to what you're trying to prove? If I'm writing down all these numbers, is that going to sway what I'm probably going to say about the sample? Probably so. So make your statement first, your HO, your null hypothesis, and your alternative. Specify your level of significance, 1%, 5%, 10%, whatever it's going to be. Then you do all this stuff that we've been doing, the X bar, standard deviation, the variance, the probability, all that stuff. Then pick a statistic that is comparable with the parameter in the null hypothesis to test that statistic. So you're going to pick the things you're going to pick. You're either going to pick mu, which is X bar. If you're in a sample, you might pick your sigma squared, which is S squared in the sample, or you might pick sigma, which is S in the sample, or you might pick the probability, which is P hat in the sample. So we're going to pick one of these in our sample and then compare that to do our test. That's what this says. I didn't realize that was on there, or otherwise I would have written all that. So we have all that stuff. The one that's left off there is the sigma. I'm not sure why sigma is left off. Remember, with these you could use the Z chart, the T chart, and the chi chart. So don't lose those charts that you had from last chapter, because we're going to need them. P-value. This is important. P-value. The probability value, the probability if the null hypothesis is true of getting this sample statistic with the value I probably should say as much or more extreme than the one determined from the sample data. So that's when I'm drawing all this, I'm saying my p-value, we want a p-value, if this is our range that we're looking at, we want a p-value that falls in here. That means our statements are going to be true, or our null statement's going to be true. If the p-value falls in here, that's an extreme value, and that's going to tell us that we have to reject the null. If we did another sample, and when I'm talking about extreme, we're saying, okay, it's out here, it's extreme. If we did another sample, we know that every sample is going to be a little different. We should get, if it's that extreme, we should get something else that falls in that range. So we know that the statement was, or the claim was, probably not true. When we talked about tires earlier, and we said the tire is rated at 50,000 miles, and we do a sample, and we showed this earlier, and it came out to be 48,000 some miles. Does that mean that the company is lying? Probably not, because that wasn't real extreme. Now, if we came out, we did a sample, and the tires that we did in the sample averaged about 30,000 miles. Is that quite a ways off? So that would probably be extreme. Now, does that mean we can just reject their claim? Maybe we got a bad batch of tires and we might want to have to try another sample. Then in the next sample, we get that the tires got 31,000. Once we do a couple of samples, 2 or 3 samples, what can we say about the company's claim? Probably a lie. It's probably false. All right? And that's what places like the Better Business Bureau, that's what they're supposed to do, stuff like that. Decide, hey, this company's lying to the people. This construction guy is going out and he's telling, hey, I'm going to do this job for $10,000, and then every job ends up being $15,000 instead of $10,000. Well, after a while, somebody reports them and they find out that he's going out there, and once you got the job half done, you're probably not gonna switch who you're doing the job through.
I don't know, but I almost got it.
So if we do this and we do another sample, it comes out as much or farther that way in that area where it's considered extreme, then that tells us that something's probably wrong. If we're in that extreme area, that's already telling us something's wrong, because we should never ever get to that extreme area depending on how big it is. All right, nature of the test. We talked about this last time. 3 types of hypothesis tests. You got a left-tailed, you got a right-tailed, and you got a two-tailed. And we talked about this earlier in the year. The type of the test depends on the region of the sampling distribution that favors a rejection of the null. So in other words, if we're here, this is where we reject the null. This is where we fail to reject the null. So the rejection area is that area that I color in all the time. This would be a right-tailed test. This region is indicated by the HA. On our test, I thought this was the other ones. We talked about this last time. Could have something that looks like that. This is the rejection region. This is your HA part. This is your HO part. That's a left-tailed. Then you have a right-tailed. This is your test statistic, whatever it happens to be. My number line's just got -3, -2, -1. Could be any numbers along through there. I'm using just the Z-scores on that. Could be, you know, if we're doing the tires, this right here in the middle could be 50,000. And this is 51,000, 52,000, so on and so on. Then you have a two-tailed. The two-tailed's always going to be the ones that have the equal to and the not equal to in it. Those are going to be your two-tailed test. So this area in here is where we fail to reject the null, and these two areas on the ends are where we reject the null. The smaller the p-value, the more evidence to reject the null. So in other words, if we're here and we make it a real small p-value out here somewhere, and we get something that falls in there, then we're probably going to really reject that null, because we were taking a very, very small p-value there. Small p-value shows an unusual event. Remember, an unusual event, 5%. What if we're on a two-tail? This is at 5% right here. What's this one up here going to be? Think of your number line. This part here would be 5%, but what's this number going to go right here if you're doing percentages? 95. So if it's above 95%, that's probably an extreme value. If it's below 5%, that's an extreme value. A small p-value shows an unusual event. You still can't say that the HO, that the null hypothesis is false. What we're going to say, and that this goes back to the politician thing that I talked about last time, we're not going to say, hey, the HO is false. We're going to say that we failed to reject the HO. So we're not sure about it. Let's skip over this. We did some of this last time. Be able to draw these. This one says, for each claim, state the HO, HA, then determine so on and so on. I think we did some of this one last time. We stated it. Our mu was greater than or equal to 2.5, even though I think I changed this one now. And I forgot something on this. What'd they say? Water faucet manufacturer, mean flow, certain faucet is less than. So this actually, I forgot this. I should have put claim in there. That's the claim. And we look at this. Our p-value is right here. Whatever that value, that statistical value that we come up with to test is right there. This is the area where we're going to reject the null And this area over here is the area where we're going to fail to reject the null. This would be a left-tailed test. All right, decision rule. So what we're going to do, and this is very important for you, so you might want to wake up right now and write this down, or at least part of it. On the decision rule, and we're going to do like 3 or 4 different ways this chapter. We're going to use the decision rule on one, and the decision rule is just these 2 things. So this is where Jacob wants to come back to me here. If P is less than or equal to alpha, so you figure out your probability, and it's less than or equal to your level of significance, then we reject the HO. So instead of looking at the graph, and we're going to look at the graph later on in the chapter, and saying, hey, our P fell in here, we reject the null. Here we're just going to compare the two, whatever the probability is. So if I tell you the probability is 0.02 and our alpha is 0.05, then the p-value is less than alpha, so we reject the null. We just compare those two. We compare the alpha and the p. P is less than, we reject it. If p is greater than, then we fail to reject it. Again, failing to reject the null, I don't know how many times I've said this through the slideshow, failing to reject the null does not mean that it's not true, or does not mean that it is true. Just tells you there's not enough evidence to say it's false. So we just don't have the evidence to prove it wrong. So these 2 things, very important. P is less than or equal to alpha, you reject the null. P is greater than alpha, you fail to reject the null. Tell me when, Jess.
I've got it.
With this chart's sort of important too. The 4 things that go in this chart, 4 things that go in these 4 areas, are going to be your explanation when you reject or you fail to reject. So decision-based rule on p-value. If your claim is the HO, if your claim is the null hypothesis, and we reject the HO, then we say there's enough evidence to reject the claim. So when you go to explain this is what you're going to explain. We say, okay, it comes out that our p-value was like we had a second ago. Our p-value was 0.02 and our alpha was 0.05. So we say we're going to reject the HO. We reject HO. Then what we can say, our explanation of that is there is enough evidence to reject the claim. So if they're claiming the tires get 50,000, we're saying there's enough evidence to reject that. If our claim is the HO, I think it goes this one next, I'm hoping. Yep. If our claim is the HO and we fail to reject it, we're not saying that they're right, that their claim is correct. We're now saying there's not enough evidence to reject the claim. So with this, if our claim is the HO, If our claim is the HO, are we ever going to prove it to be false? Never. So never can prove, or no, I'm sorry. Are we ever going to prove it to be true? If our claim is the HO. All right, I said this backwards. The other one's going to be what I was saying first. We can never prove that it's true. All we can say is we can't reject it. It might be right. We can reject it and say, no, their claim's wrong. So we can say the claim is wrong. Claim is wrong. This one doesn't say that the claim is right, though. It says we're not sure still. So if our HO is our claim, if our null hypothesis is our claim, we could never ever prove that that claim is true. And this is one of the questions that we did last time together in class. We said if you want to prove something is true, then you want to make that your what? Your HA, your alternative hypothesis. So if we want to prove something is true, we make it the alternative, try to make it the alternative hypothesis so we can try to prove it's true. If we want to prove a claim is wrong, then we make it our null hypothesis. That just confused the heck out of you, Riley, because I screwed that up
I was confused.
from 17 years ago. Your mom and dad were too, 17 years ago. Oh God, what did we do? If the claim is the HA, if the claim is your alternative hypothesis, and you reject the null, then you can say there is enough evidence to support the claim. So now you're saying that the claim is true. That's the only time, that's the only way you can prove that this claim is true. If you fail to reject it and your claim is the HA, then your explanation is there's not enough evidence to support the claim. Now, it doesn't mean that the claim is false, but we don't have the evidence to support it. So we can't say it's true either. So here we can actually say that the claim is false. The claim is wrong. Here we can say the claim is true. Both of these, when we fail to reject, we're sort of saying, there's not enough evidence one way or the other to say what it is. So again, if you want to support the claim, if you want to support the original claim, you got to make it the HA. If you want to try to disprove the claim, then you got to make it the HO. So you turn stuff around to make it which one you want it to be according to which side you're on. Now, does that mean that every time Carson supports something and he makes it the HA that it's always going to come out to be true? No, not necessarily. But if that's what he's trying to do is to support it, then you put it on that side because that's the only chance you got of proving it true. If you put your claim over here as the HO, we can never ever prove it's true. We can only prove that it's false or that there's not enough evidence to say one way or the other. Grant, that make any sense?
Yeah.
Are you lying to me?
No, that actually makes a little bit of sense.
You perform a hypothesis test on the following claim. You should interpret your decision if you reject the HO, if you fail the HO. So our claim is HO, that's our claim. A university publicizes that the proportion of its students who graduate in 4 years is 82%. So we're saying our HO is P equals 82% or 0.82. That's our claim. If we reject the HO, what are we saying? If we go back to this and we reject the HO and the HO was our claim, then what are we saying about the claim? It's false. There's enough evidence to reject the claim. So if this is our HO, we're saying that the university's lying, the probability that you graduate in 4 years isn't 82%. Now you gotta be careful with this sometimes, because could the probability be 88%? Yeah, because they didn't say at least. So they're saying it's exactly 82%. So if we wanted to prove the university wrong, they just made it easy for us, because maybe it comes out to be 83%, and we say, they were wrong, even though it was a higher graduation rate. If we fail to reject the HO, so we fail to reject this, fail to reject the HO, and the HO was the claim, what can we say about the claim then? Not enough evidence to say one way or the other.
I would write that out.
All right, that's right like that. There's not enough evidence to reject the claim. You just write that out. Those 4 phrases right there is going to be like your explanation for each of these. Now, it might be better off if for a certain problem. So if we go back to this problem, instead of just writing out, there's not enough evidence to reject the claim, we write, there is not enough evidence to reject the claim that 82% of the people graduate in 4 years. We might tie it into that problem. We already said all this. So that's how you would write out. There's insufficient evidence to indicate that the university's claim of 82% is false. We can't say that there's enough evidence to say that. It's the same thing here. If you reject the HO, we got that. This is probably important to write down. This is the steps for doing a hypothesis test using, if I can ever move this, using a p-value. First thing you're going to do, steps you're going to do, you're going to state the HO and the HA. These boxes, ignore those boxes. That's just where I had HO, and for some reason the PowerPoint didn't like it. Had HO, HA. Second step, specify your level of significance. Find your alpha. So these are the steps you're going to do on each of these problems throughout the chapter. First thing you do, you state your HO and HA. There probably should be a step above this. Number 1 should probably be write claim as math. Write the claim in math form. Then you state your HO and HA. So you write your claim, P equals 82. Then you find your level of significance. Normally they're going to, just like with our level of significance that we've talked about in the past, normally they're going to tell you, hey, use a 95%. Remember the confidence level when they told us 95, 99? They're going to tell us 1%, 10%, 5%. Normal. Not always, but normal. Next thing, determine the standardized sampling distribution and draw its graph. Going back to this, you've got to be able to draw this normal curve. We're going to use this normal curve a lot this chapter. And you're going to have to draw it a whole bunch this chapter. Is this center number always going to be 0? Could be anything, all right? It's 0 if we're using like a z-score to do this stuff. Could be, going back to the tires, could be 50,000. If that's our mu, if that's what we're looking at. So be able to draw that normal curve. Is it real hard to draw that normal curve? I know Jesse's not going to draw a curve. He's going to draw a what? A hill. He's going to draw a hill. Curves aren't in the hillbilly Preble County vocabulary. Big hill. Number 4, calculate the test statistic and its standardized value. So here it's saying put it on the z-scores where we got 0 in the middle, but sometimes that won't always happen. Calculate the test statistic. So we're calculating that statistic right there, seeing what it is, and we're going to put it on our graph. And what that tells us, this is stuff where we reject the null. That's stuff where we don't reject the null, where we fail to reject the null. But we're going to calculate that number, whatever that statistic is that we're looking at, whether it's a percentage, whether it's X bar, whether it's standard deviations, variance, whatever it happens to be. Next step, find the p-value. You're going to do your sample and you're going to find the p-value. Remember, p stands for probability. Find that p-value. And then you're going to use this decision. Is the p-value less than or equal to level of significance? Remember, your level of significance is your alpha. If no, if it's not, then you fail to reject the null. You accept whatever the null says. No, you don't accept it, you just fail to reject it. You say, we can't do anything about it. Just let it go. If the p-value is less than, then we reject the null. So p-value is more than, so p-value is greater than or equal to your alpha, you fail to reject. If p-value is less than or equal to alpha, and I'm saying this wrong, one of these is, that one should just be greater than alpha, and that one's less than or equal to. So we reject or we fail to reject. And this is just steps for using a hypothesis test using a p-value, using a probability value. Number 7, write a statement to interpret it. That's where this stuff comes in. We reject the null. There is enough evidence to say that we reject it, whatever it comes out to be. So those are your steps. I think for the homework tonight, I'm not sure if any of them actually have you figuring out a p-value or anything. I think most of them are just, they're giving you a p-value and you're deciding and you're writing a null and stuff like that again, I think. Grant, what's your grade for the 4th 9 weeks? Yeah, you do.
At least a 90.
That's not average.
No. I'm saying, what is it right now?
Probably 100.
There you go.
Mine's a 0.
So you can go home and tell Marty that you're 100 times better than Jesse Schaefer. That's your assignment. But Jesse's going to jump his up 50% come Friday, right?
I mean,
It's a yes or no question.
no, I'm saying
It's a yes or no question.
unless you grade the last game, then I'll get a 100. You know?
You know what I say?
So the only part of that I heard was that last word. No.
It's like,
But it's not going to jump it up.
I'm going to. But if I do this, then at least give me half credit on my notes. I mean,
No way. I sat here and watched you copy it off there.
No, you didn't. You don't know what I was just like. Can you prove it?
Do I have to prove it?
Yeah.
No, I don't, because I'm the one that decides what grade goes in the grade book, and this is what I decided.
You're doing that because you don't like it.
You can do this.
You hate